This is a video from section 1.3 in a linear algebra class. Let's look at the following definition. A matrix is a rectangular array of numbers. Let's look at some examples of matrices. In example 1, we have the matrix 3, 0, negative 1, 2, 1, 1. In example 2, we have the matrix 4, negative 1, 0, 2. In the third example, we have 1, 4, 2, 3, 1, 5. In example 4, we have the matrix 1, 5, 2, negative 1, 0, 1, 3, 2, 4. In the fifth example, we have the matrix 2, 3, 4, 0. And in the sixth example, we have the matrix 4, 3. The dimension of a matrix is described in terms of the number of rows and columns. So let's circle back to our first example. In our first example, we have the matrix 3, 0, negative 1, 2, 1, 1. And I want you to notice we have 1, 2, 3 rows, and then we have 1, 2 columns. So this here is a 3 by 2 matrix. That's the size of the matrix, or the dimension of the matrix. Number 2. So suppose we have the matrix 4, negative 1, 0, 2. If you notice, there are 2 rows and 2 columns. And so this is a 2 by 2 matrix. 2 rows, 2 columns. If we look at example 3, we have the matrix 1, 4, 2, 3, 1, 5. And so notice how there are 2 rows, 1, 2, and then there are 3 columns, 1, 2, 3. And I'll just circle a column here. That would be considered a column. So there's 3 columns, 2 rows, 3 columns. And so this is a 2 by 3 matrix. If we look at example 4, we have the matrix 1, 5, 2, negative 1, 0, 1, 3, 2, 4. And this right here is a 3 by 3 matrix. Example 5, we have the matrix 2, 3, 4, 0. So in here we have 1 row, 4 columns. So this matrix is 1 by 4. And then the sixth example, we have the matrix 4, 3. And so this is 2 rows, 1 column. And so we call this a 2 by 1 matrix. Now, a matrix with only 1 column is called the column vector. So again, I'm just going to write that real quick here. A matrix with only 1 column is called a column vector. For example, if we go back to example 6, that's a 2 by 1 matrix. So notice there's 2 rows, 1 column, and hence that's a column vector. Now, a matrix with only one row is called a row vector. So a matrix with only one row is called a row vector. And if we look at example 5, that's an example of a row vector. So here, I'm going to write down the matrix 2, 3, 4, 0. So notice that's one row, 4 columns. Now, we use capital letters to represent matrices. That's pretty typical. We use lowercase letters to represent numbers. And numerical quantities are often called scalars. Numerical quantities are often called scalars. Now, the entry in the ith row and jth column of a matrix A, so let me write that down. The entry in the ith row and jth column of a matrix A will be represented by A sub ij. So again, I is the row that the entry belongs to, and j is the column that that entry belongs to. So it's in the ith row, jth column of the matrix. And so, for example, suppose I let A equal the matrix 1, 4, 2, 3. 2, negative 1, 5, 6. 7, 8, 9, negative 10. Doesn't matter. Now, what's the size of the matrix? There are 3 rows and 4 columns. So can we agree that this is a 3 by 4 matrix? Now, suppose I want to know the entry A21. Now, that tells me to look for the entry in the second row, first column of matrix A. So this is the entry. Let's write that down. In the second row and first column of matrix A. Well, if we look, that tells me a sub 2, 1 is going to equal 2. That's in the second row, first column of the matrix. So a sub 2, 1 equals 2. Suppose I want a sub 3, 3. So that means I want the entry in the third row, third column of matrix A. And that's right here. And so A33 or A sub 33 is equal to 9. A sub 14 is equal to 3, right? See, A sub 14 is the entry in the first row, fourth column of matrix A, etc. And this is a good stopping point for this video. This is a video on section 1.3, and we looked at the definition of a matrix, examples of matrices, dimension of a matrix. We defined a column vector, row vector, and we identified the entries of a matrix, what that looks like, and how we write them. And so this is the first part of my notes for section 1.3. So, okay, thank you.